Take a look at this rock here behind me. It's a boulder, which is one of the largest pieces of sediment. It probably broke off of that cliff up there and rolled down the hill to here. But it rolled down in one piece, and now for some reason it's into a couple of pieces. Well, this is an example of physical weathering, and more specifically frost wedging. What happened is this rock had some cracks in it, and this is a place where it rains a lot. It's also a place where it gets very cold. I'm in Iceland. So the rain got into this little crack in here on the rock, and in wintertime, when it got cold enough, the water froze, it expanded, and then all of a sudden we've got two pieces of rock instead of one big rock. Once again, this is physical weathering. It's taking one thing and breaking it into smaller pieces without changing what it is. More specifically, this is an example of the physical weathering that we call frost wedging. When water gets cold, expands, and that causes the big piece to break into smaller pieces. Once again, frost wedging. Okay, so we know that rocks break into smaller pieces. You can see this small piece of rock, you can tell where it came from. It was once part of that cliff up there, which is an old lava flow. And what's happened over time is water probably got in there, maybe it froze in the wintertime and expanded and broke the rock into smaller pieces. That's weathering. Well, then those smaller pieces get pulled by gravity downhill to the bottom of the hill. That's erosion. This is how weather and erosion go together. Well, these small pieces that were weathered and then eroded that wind up down here at the bottom of the hill have a name. It's called talus. T-A-L-U-S. Talus is the pile of weathered pieces of rock that you wind up with at the bottom of a hill. So here we've got a big chunk of rock, and this rock is being broken down into smaller pieces a couple different ways. And one example I want to show you is what's happening with this tree right here. If you'll notice down at the bottom where the tree is growing, the rock is being split into smaller pieces. This is a type of physical weathering. Remember, weathering is breaking something down into smaller pieces. Physical weathering is when it's the same rock that you started with, it's just down to a smaller piece. And we can see right here, that tree, the fact that it is growing inside of the rock is breaking it into smaller pieces. What happened was a seed from a pine tree fell into that little notch in the rock, and it was able to start growing. And as the tree grew bigger, the roots got bigger and pushed their way further into the rock, and they expand. And when the roots expand, the rock ends up cracking. As this tree grows bigger and bigger, this rock is going to break into smaller and smaller pieces. This is a type of physical weathering that is called root wedging or root pry. It's very simple to understand. It's the action of a plant or a tree growing where their roots are the cause of the rock being broken into smaller pieces. Okay, so what we've got here is a very special circumstance of weathering. And remember that weathering is rocks breaking down into smaller pieces. Well, what you see behind me here is Stone Mountain, which is basically just one big, huge rock. And millions of years ago, this big blob of rock was under the ground. It was covered up by a bunch of other dirt and other types of rocks. Well, over time, because of erosion, all of the stuff that covered up this rock has been eroded. It has gone away. It makes sense. It rains a lot here in Georgia, and you're going to have a lot of water moving stuff around. Well, this rock here, this granite, is a lot tougher. It doesn't break down as easily. But what we can see happening right here is a big kind of sheet or chunk or layer of the granite that has now obviously broken off from the main body. What's happened here is the process that's called exfoliation or unloading. And so long as Stone Mountain was underneath a bunch of other stuff, the pressure kept all of the rock together. Well, now that we have unloaded a lot of the pressure, we'll get sheets and layers, just like the layers of an onion, that start to peel off of the main part of the rock. So now we've got a smaller piece of the rock that has broken off the bigger piece. That's what weathering is. So once again, this is a type of weathering called unloading or exfoliation, where you get rocks breaking down because of the relieved pressure that holds it together. So today let's talk about weathering and the formation of sand. Now all sand is a size of sediment. It's a piece of rock that's been broken down into a certain size piece that we call sand. So all sand comes from some kind of parent rock. The parent rock is the original rock that is being broken down into sand-sized sediments. Well, behind me, we see a huge collection of rock. This is a lava flow in Hawaii, and all of this lava hardened into solid rock. That's what we've got right here. We've got a nice, big, huge chunk of solid rock, and if it is broken down, it will make sand. Well, what's going to do the breaking down? We know that the #1 agent of weathering is water. And here's our water out here. We also know that weathering is going to happen faster if there is a lot of water and if the water is moving very quickly. And you can see here the action of these waves, because there's nothing out there to block the wind for hundreds, even thousands of miles. This side of Hawaii gets hit by pretty strong waves all the time. And all of that water constantly hitting this rock is going to break it down into smaller and smaller pieces. Now it also helps that this particular lava has a lot of open spaces in it. It is said to be very porous. So when the waves from the ocean hit this lava, they can get into and touch the rock more than if this rock didn't have these open spaces. So the more porous a rock is, the faster it will break down into cobble-sized pieces from boulder-sized pieces, and subsequently from cobble-sized pieces into pebble or gravel sized pieces. And eventually, if this process happens more and more, we can break this down into sand sized pieces. So all of that water is hitting that rock and breaking it into smaller and smaller pieces. Here we can see some of the cobble sized pieces or pebble sized pieces. But the water hits this rock 365 days a year, 24 hours a day, until finally it breaks it into sand-sized pieces. This particular sand is still pretty coarse. It's not really fine sand yet, because this beach is actually brand new. This sand has all been formed since the volcanic eruption in 2018. So this sand took less than a year to form. And that's partly because of a couple factors. One, this lava is exceptionally porous, so the water can get in there and do its work pretty quickly. Two, the waves and the wind are very strong here, so the water does its work more quickly. If we come back in another year, a lot of this sand will then be pulverized into a little bit finer sand like we're used to on beaches. So that pretty much explains to you the process by which sand is formed from its parent rock by a process that we call physical weathering. So here I am sitting on a nice, pretty new black sand beach in the state of Hawaii. And this should beg the question for you, why are some beaches black? Why are some more brown? Why are some more yellow? Why are some pure white? It all has to do with the parent rock from which the sand was formed. Remember that sand is merely a sized particle. It is some rock that was broken down into a piece small enough that we can then call sand. Well, here in Hawaii, parent rock is this nice dark basalt lava. So when you break this down into smaller pieces, into sand-sized pieces, you wind up with a black sand beach. Well, in Florida, in Georgia, in our part of the world, we don't have these nice, pretty dark black rocks that get broken down into sand-sized pieces because we don't have volcanoes where we are at. What we have are rocks that look like this. This is a calcium carbonate based rock. It's from an old coral reef, or it's from seashells that have been broken down and squeezed together. And you can tell when this rock is broken down, you're going to get a nice, pretty white sand beach that we're typically used to in Georgia. So to summarize, why are beaches different color? Because the sand is coming from different colored parent rock. So here I am on the coastline of the big island of Hawaii, and it seems like we have the perfect set of circumstances to make ourselves a nice beach. We've got some rock here, and we've got a lot of water, and we can see it's moving pretty fast, and you can see how it's breaking the rock down into smaller pieces, which is physical weathering. And if this happens enough, and the water's going to hit this coast 24 hours a day, 7 days a week, 365 days a year, we should have a beach here before no time, because that water is going to break the rock into smaller pieces into sand-sized sediments. But we don't have a beach here. There are almost no beaches on this side of the island. And let's talk about why. It's not that weathering isn't happening. It's not that this water doesn't break this rock into sand-sized pieces. It does. But because the water is moving so fast, it is able to move those sand-sized sediments away. Remember, it's weathering and erosion. Erosion is the movement of sediments. And in this case, as soon as that rock gets broken down into small enough pieces, the water too easily moves it away, and hence we have no beach. So here we got a couple of rocks sitting in a beaker full of hydrochloric acid. And you know what acid does. It tends to eat away at things and dissolve them. But it doesn't look like these rocks are having much happen to them. Don't appear to be being broken down or weathered. So we'll take this rock though, a little bit different type of rock, and we'll drop it in. And notice what happens. Now we have a chemical reaction happening here. What's happening is the acid is reacting with some of the minerals that make up that rock, and it is forming something new. That's the bubbles. That's the carbon dioxide gas. That rock was not emitting carbon dioxide before I interacted it with the acid. So this is an example of a chemical reaction, which leads us to chemical weathering, which is where we get the rock being broken down into something new that it wasn't before. The rock wasn't a gas before, it is now. So I'm going to pause this and we'll come back and we'll look at this in just a few minutes and see how it looks different. So here, after about 5 minutes, it's still reacting, it's still going, and it's kind of hard to tell as of yet, but the rock is now a little bit smaller than it was when I put it in there. We'll come back and take a look at it again in a few more minutes. So now you notice the rock is basically entirely gone. It has been broken up into really small pieces. But the rock isn't there anymore. It's not a rock. It's not just smaller pieces. It's been broken up into its composite minerals. This is an example of chemical weathering, where the rock was broken down, but it was changed into something else in the process. And different rocks weather chemically different than others. You can see the yellow one and the red one did not chemically react with the acid, whereas the white one did. So once again, this is an example of chemical weathering, or where the material is broken into smaller pieces as it is being changed chemically into a new substance. So here I am in Lake Tahoe, California, and I'm sitting on top of a big rock. Now, this rock is granitic in nature. It's made up of a bunch of different little minerals. And we've talked at length about how big stuff can be broken up into smaller stuff, primarily by the action of wind or water. And we know that the more water there is and the faster it moves, the more stuff is going to be broken down and then carried away. That's weathering and erosion. Now, this rock here is extremely tough. And if you look around, we can see some little pits here where some of the rock has obviously been broken down. But this rock here is not in a stream. You don't get really fast water. All you get is rain that collects on top of the rock, and somehow or another it moves the rock away. It breaks the rock down. Well, this is a good example of chemical weathering. Chemical weathering is when something happens that changes the rock into something else, and that new material is much more easily moved away than the parent rock. So this granite here by itself really can't be moved. It's really tough to break down. But if you get a little pool of water like this right here after it rains, some of these minerals in the rock dissolve into the water kind of easily, and it makes a slightly acidic solution. And we know that acids tend to eat away at things and dissolve things, and that's exactly what happens here. So places where you get water that can collect and it can sit there, it can dissolve the minerals and make a slightly acidic solution and then dissolve the rock. Well, the rock then dissolves and it's not the rock anymore. It's the residue. And the next time it rains, that residue is floating in this water. When it rains and this puddle fills up and the puddle overflows, it takes the residue from where the rock was dissolved and takes it on down the way. So this is an example of chemical weathering, where the rock was changed into something else by the acid and then moved away by erosion. So here we are at a hot spring in Japan, and this hot spring water is coming up out of the ground as steam, and when it does, it's bringing a lot of minerals with it. The rock in this area was mostly this basalt. It was dark black rock. But a funny thing happens when all of these minerals interact with that basalt. What happens is chemical weathering. You can see that that rock doesn't look like what it used to. What's happened is that rock is reacting with the chemicals and the minerals in the hot spring, and it is changing the rock into something new, which breaks down differently. That's an example of chemical weathering. When you take a rock like this and you change it into something else, that's chemical weathering. So let's look at another example of hydrothermal alteration, which is a type of chemical weathering, where rock gets broken down into smaller pieces. As you can see here, this is a hot spring, and the water is coming out at an elevated temperature. Well, let's take a look at this rock. You can see this rock here, and I can scrape it with my poker. It's pretty tough. I really can't get much to come off of there. It has kind of an orangish color. But if you'll notice, where this hot spring water, loaded with its minerals, meets the rock now looks different. It has this white. It looks like it has been changed into something else. And you'll notice now, I can very easily break it apart. So this is an example of hydrothermal alteration, where this hot water is changing this rock into something new. And this something new gets weathered a lot more easily than the original rock. So take a look at the rock formation back here behind me. Notice we've got this darker rock up here, and we've got this lighter rock down here. These are obviously two different types of rock. Now, this rock is sitting outside in the open. It is being weathered all the time by wind and rain. But different materials break down or are weathered differently. And what we can see here is that this dark rock up at the top is not being weathered as fast as this rock down here at the bottom. This is what's called differential weathering, where you get two different materials that weather or break down at different rates. So this rock down here at the bottom is going away, is being broken down and moved away faster than this rock is up top. And you can see there's more of this rock up on the top than there is at the bottom. So once again, this is an example of the differential weathering, where you have different materials that break down at different rates. This specific example is found at Mushroom Rock State Park in Kansas, and you can see why we have this called Mushroom Rock. It's a result of differential weathering. So this will give you some idea about how tough and resistant to weathering granite is. This is on the side of Stone Mountain, which is one big huge chunk of granite. If you'll notice, people used to come up here and used to carve their names into the side of the mountain. And we see this here, 1878, and it still looks crisp enough to read. And this is right in the path where people walk over this, and it still hasn't weathered and broken down. So this shows you granite is a very tough rock, very resistant to weathering.